Hello everyone, my name is İlhan. I'm going to present my Physics 101 project. In this video, we will examine the mechanism called ballistic collision, which is a type of momentum conserved and mechanical energy non-conserved collision. Nevertheless, we will also make energy conservation calculations in the later stages of the experiment. A ballistic pendulum originally consists of a large block, generally a wooden block, suspended with strings to the ceiling like a pendulum. However, in our experiment, we used Play-Doh instead of wooden block. Again, in order to avoid some risks, we prefer toy gun and toy gun's bullet. When a bullet, Nerf bullet or toy gun, is shot into the block and becomes embedded, the center of mass of the combined system rises some distance, h. By measuring this height, the bullet speed can be found. Our equipments are consisted of dough, a mechanism that dough is hung by strings, toy gun, balance, ruler, and scientific calculator. This is our experimental setup. First of all, I use balance to measure the masses of bullet and Play-Doh. After these data were recorded, I move on to perform this experiment. As you can see, I didn't shoot the bullet from far away so that I would minimize air friction. After the collision occurs, combined system start to swing up and down. As you can see easily at the peak point, combined system seems like a stationary position, and my aim is to measure the height at this point. Thanks to the data provided by the camera, I determined the height at this point. Afterwards, I started to make some theoretical calculations. During the collision, since the horizontal momentum is conserved and during the oscillation mechanical energy is conserved, I got some equations. And using these equations, I could reach the initial velocity of the bullet. In addition to the velocity one, the theoretical velocity of the bullet, which I found theoretical. I also measured the bullet speed, which is completely experimental. In this part again, and I fired my gun from a particular distance and used chronometer, and I found completely experimental velocity of the bullet. Afterwards, I compared to the theoretical and experimental velocities, and I calculated the percentage error according to these data, and I found that the average percentage error is 13. These errors stemmed from, in particular, the existence of air friction and rotational kinetic energy. Thank you for listening to me.